Welcome to the Podkey summary of Explore Immersive Website Environments in visionOS from WWDC 2026. This one is a really practical look at how immersive web experiences are starting to feel more like normal web development, just with a lot more spatial weirdness in the best way. The big ideas are familiar APIs, smarter loading so giant 3D assets do not hit everybody by default, and a bunch of small technical choices that make immersive scenes feel grounded, believable, and actually usable. And maybe my favorite part is how much of this comes down to plain old web instincts. Keep it performant, keep the UI clear, and react properly when the state changes. One of the nicest details here is that the immersive API follows the same pattern developers already know from the full-screen API. So instead of learning some totally alien model, you call request immersive on a model element, kind of the same way you'd call request full screen on a video. That matters because it lowers the mental overhead right away. You do not have to stop and relearn how the web works just because the content is spatial. There is also an important difference from full screen. Full screen takes over the browser view, but immersive mode pushes the model beyond the browser while the page itself can still remain visible, which means you can have something like a full-screen video and an immersive environment at the same time. That's a very different kind of composition than the old one-screen, one-mode web. A lot of this work is about point of view, literally. By default, an inline model preview tries to fit itself nicely into bounds, which is useful until you need a very specific camera position. The workaround is pretty elegant. Set the model's entity, transform to an identity matrix, so you can override that default behavior, then apply your own translations and rotations. That lets you place the view at eye level instead of accepting whatever the generic framing would have picked. Then a JSON map of seat coordinates comes in and does the real magic. Each seat gets its own translation and orientation values using the standard Y-up coordinate system. So, if someone picks a particular seat, both the inline preview and the immersive version can reflect that exact perspective instead of a rough approximation. It's one of those details users may not describe in technical terms, but they absolutely notice when it feels right. There is also a very web-minded performance trick here, and honestly, it is refreshingly simple. If you set the model element to display none, the inline preview stays hidden, but request immersive can still work. That means the heavy USDZ asset does not have to download until the user actually chooses to enter immersive mode. For big environment models, that is a big deal. You're saving bandwidth and memory for everyone who just scrolls by and never opts in. That kind of lazy loading is not flashy, but it is exactly the sort of thing that keeps immersive features from becoming a tax on every visitor. A few of the standout features here are about realism, and they are surprisingly concrete. Video docking lets a full-screen video get placed onto a surface inside the 3D environment, so the screen reads like part of the room instead of some flat overlay floating on top. And with custom reality kit annotations on the TV mesh, the light from that video can spill onto nearby materials. That sounds like a small effect until you picture it. The room starts responding to the video, which is the difference between seeing content in a scene and feeling like the scene contains it. The same thinking shows up with Safari window shadows. If the browser window can cast a shadow onto the 3D scene, users get a much better sense of where that window exists in space. A low-poly mesh with a scene understanding component receives that shadow, which is a nice balance. You get the spatial grounding without spending performance on geometry nobody needs to admire. A lot of the polish depends on asset prep, which is less glamorous than the demo, but usually where the win is. Reducing vertex counts and cutting down the number of entities helps immediately, especially when you remove invisible meshes and merge objects that do not need to stay separate. You are lowering render cost without changing what the user actually perceives, which is pretty much the dream. Baking lighting into textures is another practical move, and compressing USDZ textures with USD Thrush helps both download speed and runtime performance. So the immersive experience is not just more beautiful, it is also less demanding, which tends to make every other design choice easier. One especially useful workflow detail is that these advanced behaviors do not have to be hacked together later with extra runtime scripting. A custom Blender plugin can add Reality Kit components directly into the USDZ during authoring. That is how things like video docking regions and scene understanding tags get embedded in the asset itself. And once those annotations are there, you can enable features like light spill, shadow receiving, and interactive animations much more cleanly. It's a nice reminder that immersive quality is not only about what happens in code. A lot of it starts in the pipeline. The usability side here is just as important as the rendering tricks. Inline mode and immersive mode do not share the same reference frame, so developers need to listen for the immersive change event and recompute transforms when that switch happens. If you do not respond to that change, the UI and the scene can drift out of sync in ways that feel confusing fast. There is also a broader point about respecting platform behavior. Users should have an explicit exit button, and the Vision Pro digital crown should still work as the normal way to dismiss the immersive session. That is one of those trust-building details. People are much more willing to enter a spatial experience when they know exactly how to leave it. And this whole idea extends beyond 3D models too. Adding the controls attribute to an image can expose native UI for platform-specific actions, like wrapping a panorama around the user in visionOS. A single HTML attribute doing something spatially interesting is a very web sort of delight. Taken together, this all paints a pretty encouraging picture of immersive web development, getting more practical, more familiar, and a lot less wasteful. The fancy parts are fun, but the real story is that good immersive experiences still come from good fundamentals, clear APIs, careful assets, and respect for how people actually use the thing. Even in spatial computing, a lot of the magic is still just solid craft wearing cooler glasses. This episode was generated by Podkey. Create your own at podkey.fm.